Today we're going to take the steps that we need to take in order to actually draw slope fields. So what we're going to be doing when we draw slope fields is we're going to be creating a table. And each time I draw slope fields, you'll see me create a table. So right now, all we're going to do is complete the table that was given in the book in order to determine the slope field. So all we're going to do is plug in numbers. That's all this means. We will be doing this and drawing the slope field on the next problem. So what it's telling me to do is that it's saying the slope of the line when y is 2 and x is negative 4, well, what is that? Well, that happens to be 6 when I plug those things in. Then in the next part it says, okay, well, what's going on now when y is 0 and x is negative 2? Well, the slope now changes, and it's 2. So what happens at the point 0, 4? Well, when y is 4 and x is 0, the slope is 4. Now we'll look at 2, 4. So when y is 4 and x is 2, what's the slope? Well, it's 2. And we'll just keep going and plugging in things, and we find out when y is 6 and x is 4, we have a slope of 2. When y is 8 and x is 6, we have a slope of 2. This is the type of table we are. Alright, so my first example looks like this, and as you can see I have a graph here ready to go to draw in a slope field. What I don't have is I don't have a table. We're starting out with an easier one. There is only an x to plug in. So I'm only going to put on my table x and dy over dx. So what I'm going to start with is I'm going to start with what creates a 0 slope. And I noticed that that's 3, so I'm going to put 3 in here first. And anytime x is 3, I know the slope of the tangent lines to the curve will be 0. So what I'm going to do is actually make marks all the way through on this diagram. I am going to go ahead and add a few more dots here for this problem so we can see it fully. So at 3, when x is 3, which would be right here, the slope of the tangent lines are 0. So what I'm going to do is draw these little tangent lines to the curve all the way through when x is 3, because x is 3 here, at 3, 0, it's 3 here, at 3, 1, and it's 3 here, at 3, 2, and so on. So we're going to make all of those. We're going to fill in this whole graph with a bunch of segments that represent the tangent lines to the curve. Let's go ahead then and plug in things that are next to it. So like 2. If you plug in 2 here, we get 1 for our derivative. So I'm going to draw slopes of lines at 2 that look like they're 1. So 1, the slope of 1 looks like this. It's increasing. It's basically a whole diagonal. Notice I'm doing that all the way down when x is 2, because everywhere x is 2, the slope of those tangent lines of the curve would be 1. Now we're going to plug in 1, and then I plug in 1, I get 2. So that means the slope is going to be more steep here when x is 1. Again, I'm going all the way up and down this whole curve. And now let's go ahead and go on the other side, because I'm just going to keep getting steeper and steeper. Let's try at 4. So at 4, I end up with a negative 1. So negative slopes are going down. They look like this. And then let's go ahead and put 5 in here as well. 5 would give me negative 2, so they would be more steep. And I know I don't have those points there, but you guys have the idea. So what this does is create this general curve of what this line or the original equation would look like. It does want it to go through 4, 2, so that the particular solution goes through 4, 2. What would that graph look like? Well, it basically looked like this, where it's curving down. You can see that from the graph. And it's curving down over this way, which makes a parabola, which if you were to integrate both sides of those, you would get a negative x squared. I'm going to do another one where I sketch the slope field, and then I'm going to use that slope field to sketch the solution that passes through that given point. Now in this problem, since my derivative actually, or the slope of that tangent line to the curve, is y minus x, I am going to create a table that has x, y, and dy over dx. One of the things that's really helpful to do is to always figure out where the derivative is 0 and where it does not exist. That will help us create a graph much more quickly. It gives us an idea about how the curve is starting to look. So what I'm going to do is I'm actually going to ask myself the question, well, what if the slope of the derivative is 0? So what if the slope of the derivative is 0? What happens with your x's and y? When does that happen? Well, when, let me go ahead and move that on the other side. Add x to both sides, I get x equals y. So dy over dx equals 0 when x equals y. So I can actually create quite a bit for my table here having this piece of information. So anytime x and y are the same, the derivative equals 0. So when it's 0, 0, or when it's 1, 1, or 2, 2, the slopes are always 0. Now I could list a bunch more, but I want to save some room on my table. So I'm going to go ahead and put, here's 0, 0. There's the slope of the tangent line is 0. Here's a little segment showing the slope of the tangent line is 0, and here at 2, 2. Now following that same idea, I can also just go ahead and continue that onto my slope field, and I can see that I'm going at a diagonal. So what I'm now going to do is I'm going to pick some other points here, and I'm going to change colors so you guys can see the difference. So I might just want to pick a point here. I'll pick 0, 1. So when x is 0 and y is 1, what happens? Well, I put 1 minus 0 in here, and I get the slope of the tangent line of the curve is 1. So at 0, 1, I have the slope of the tangent line of the curve is 1. Let's try this diagonal thing again. So if I plug in 1, 2, 1, 2, well, I plug that in over here. 2 minus 1 is 1. So it's going to hold true. I can actually just go ahead and finish up all the dots in those diagonal. All those points are going to have a slope of 1. And you could sit there and plug in each one, but I just don't think it's necessary. We've kind of proven that just with those two. Let's go on the other side here. So let's look at 1, 0. So when I plug in a 0 for my y and 1 for my x, I get a negative 1. So I will draw a tangent line to the curve right here that shows negative 1. That will look like this. And if I tried that for 2, 1, that would be 1 minus 2, so I'd get negative 1 and a negative 1. So I can go ahead and fill in my diagonals again. And let's go ahead and keep going with this just a little bit longer. I will try 2, 0. 2, 0, if I put that in there, that would be 0 minus 2. So I did 2, 0. 0 minus 2 would be negative 2. So that's more steep, something like this. And we could continue on with that. I'll go ahead and go back to green. If I plug in 3, 0, that would give me a slope of negative 3, so even more steep here. Now, as the steeper you get, the harder it is to draw in those little tangent lines to the curve. Let's go on the other side then and finish this up. If I plug in negative 2, 0, that would give me 0 minus negative 2, which would give me a positive 2. So I'd be more steep here, maybe not quite that steep as steepness of 2. And then if I plug in 3, 0, I'd have 0 minus 3. Negative 3, 0 would be 0 minus negative 3, which would make it even steeper of a 3. So you can see what this looks like. Now, what I'm going to do is find the particular solution that goes through 2, 2. 2, 2 is right here. So when I try to draw in that curve, I'll do that with a highlighter. It would look something like this, and then curve down something like this. We could say it's in that general position.